In each of the following reactions, we are going to identify the Bronsted Lowry acid, the Bronsted Lowry base, the conjugate acid, and the conjugate base. Now, if you will recall, in Bronsted Lowry, we have a little bit different. Remember, an acid is a proton donor, so that's an H+, and a base is a proton acceptor. So when I look at this first one in A, I know that water can be an acid or a base. So I think it's probably maybe the easiest, but we can start with whichever one you want. Let's do the left one first. So how does this right here change on the other side of the arrow? Well, I noticed that it has added an H plus right here. So that means it is a proton acceptor. So these two are tag teamed and these two. So we said this first one here, so this one's going to be the base because it's on the counterpart on the right hand side has accepted a proton. That means that the water this time is an acid. Now, what do you know about conjugate acid and conjugate base? Well, they kind of go with the opposite, right? So whatever my base is, then this one is going to be the conjugate acid. And if this is the acid, this is going to be the conjugate base. So let's take a look at this one down here on the second one. Now when I look at that, I look at the first one, I know that 99% of the time acids start with an H, right? So I need to find my pair. So this has an NO3 and all the way over on the right has an NO3. And then that means that water and the hydronium ion are tagged up as well. So in this case, this is your acid, right? Because I am losing a proton over here on the right, making this a conjugate base. Well, if this is the acid, that means water this time has to be the base, and the base always pairs up with the conjugate acid.